right, so for today's topic, we're going to be discussing the three main types of distribution for statistical data graphs. We're going to talk about a left-skewed graph, a symmetric graph, and a right-skewed graph. And we'll talk about what could make these things skewed. So first of all, here is a symmetric graph. Let's start off with that. So this is symmetric, or bell-shaped, and it is bell-shaped, barring my artistic abilities. And so for this, what's going on is you have some stuff out here, but the majority of the data is all centered around some central value. That central value usually being referred to as the mean, although there are several ways to measure central tendency. So we have the mean, which is where you add up everything and divide by the total number. That's usually represented by this mu here. And then you have the median, which is where you list out all the numbers and you just take the one that's in the center once you list everything out in order. And so for a symmetric distribution, the mean is approximately or perfectly equal to the median. So if you add them all up and divide by the total, you get some value. That's about the same as if I listed out the values and took the one in the middle. And if you had two in the middle, you would just average them. So that's for a symmetric distribution. Most things fall under a symmetric distribution. You have a few people who are really low or really high on whatever it is that you're analyzing, but most people fall around some central value, the average, right? That's a symmetric distribution. Let's talk about left-skewed. If you had a left-skewed distribution, then what would happen is that on the left side, right, you've got this push and it doesn't start rising up. And then suddenly all the data sort of swells up on the right like this. This one might be a little bit exaggerated, but I want to point out that you've got a left skew going on. So there are data values here, they're not zero. And the reason it's left skewed is, first of all, the mean, if I add up everything and take the average, the mean here would actually be less than the median. And what's causing this left skew is that you've got some values that are much smaller, like way smaller than most of the rest of the values. So when you add that in, that affects the mean, but it doesn't really affect the median, because if I list everything out and take the center, having a few guys who are small would just bump this down a little bit, and it's still in the average. So an actual example of a left skew would be, let's say you had a class of 30 people. Let's say 27 of those people got between like a 77 and an 85 on the test. Let's say that was most people. Let's have that one person over there who's got 100, always there. And so most people got around like a high C to a B, right? Most of them are right here. But let's say you had two people in that class who got like a 5 and a 7. So they're like way over here. So their values are so much lower that if you try to add them up with everybody else, it brings down the mean really severely. But if you list everything out, since there's only two people down here, you still get up, and in the middle of all these values, you'd still have that high C or that B. So the left skew is caused by some outliers, some individual data points that are so low that it drags the mean down, but doesn't affect anybody else's values. That's left skew. And you can always think of it visually that if I were to take the symmetric graph and push on the left, that would give me a left skewed graph. Let's look at right skew. So if I had a right skewed distribution, something like this, and then lots of data values over here. Right skew. So just like the left skew is caused by some low outliers, a right skew is caused by some high outliers, some excessive values. So this would be where the mean would be greater than the median. So let me actually mark some of these. Let's say the mean is pink, just like everybody else. So for this, the mean would be like right here. And let's say the orange is median. And the median would be like right here. For this graph, thanks to these low liars here, this would be the mean, but the median would still be about right here. For this, the mean is going to be somewhere closer over here, and the median will be somewhere over here. Now, if you have actual data values, this distance may be more pronounced or it may be significantly less pronounced. The point is that it is less. The mean is less over here and the mean is greater over here. Now, an example of something that has a right skew would be, say you had a company and you wanted to do the average income for that company. So let's say most of the employees, let's say there's 29 employees, and let's say there's 28 employees, one CEO, and then a vice president of the company. So let's say those 28 employees make about $50K a year. Let's say the vice president makes, I don't know, $250K, and let's say the CEO makes $600K. Well, if you list everybody out, there's 21 employees, right? So then if you do the median, you're going to get a value around 50K. But if you do the mean, you're going to have all these 50Ks, and then you're adding 250K, and then 600K into that. That's going to pull the mean up. And so if you talk about the mean, and you told someone, oh yeah, if you work for this company, you might make like 100K a year, that's not really accurate, because most of the employees are making half that. It's just that the vice president and the CEO of the company make significantly more. So the median might be more representative there. And so that's an example of what would cause a right skew. You've got some outliers in the positive direction, and they pull everything up. Left skew, you've got some outliers in the negative direction, and they pull everything down. Then, of course, symmetric, everything sort of balances out. You have an average, the outliers on the left balance out the outliers on the right, and everything's cool. So there we go. That's a discussion of the difference between symmetric, left skewed, and right skewed data distributions.